Okay, here we go. So number one here, we want to first look at, I want one side to look like the other side, right? So right now, this clearly does not look like this. And so I will try to combine, I would definitely try to combine this side into one term, because notice how this is one term over here, right? I have two things over here, I have one things over here. So I definitely need to combine the two into one. That would be first step that I'm seeing. I say, I have a plus sign, and I don't notice any ones, I don't notice any squares, so it's not like I can use an identity. I just maybe need to see what can condense together. So we can do that, we can combine this side together. I can also rewrite this in terms of sine and cosine as well. So I'm going to do all of that in one step. So if I wanted to add these two fractions together, they do not have a common denominator, unfortunately, so I need to start there. I can multiply by sine x over sine x on the first fraction. I can multiply by cosine x over cosine x on the second fraction. Because if one fraction has cosine, one has sine, then the common denominator would be sine cosine. I can't take away, I can only add in. That was the same thing from Unit 9. So this first fraction, when I multiply the numerator, sine times sine becomes sine squared over sine times cosine. And so that would be my first fraction. So sine times sine is sine squared, sine over cosine, or sine cosine on the bottom. Then on the next fraction, I multiply cosine times cosine. That's cosine squared over sine times cosine. And so now I could add those together. I'm also in the same step going to rewrite my secant and cosecant. So secant is the same thing as 1 over cosine times, because there's no plus sign between those two, so those things are being multiplied. Cosecant is the same thing as 1 over sine. And so we can already see that I have a common denominator now between all this entire equation. So because these two are common denominators, I can add what's in the numerator here, and I can say that this is sine squared plus cosine squared on the top over sine cosine. Okay, so again, I cannot combine a sine squared and a cosine squared. Those are not like terms, so we just write them squished together. And then on the other side, the 1 times 1 on the top stays a 1. Cosine times sine on the bottom. Let's maybe flip that around. Remember, multiplication is commutative, so I can flip the order. And so now it looks exactly like the other side. And so you can do a couple things. You can try to plug it. There's so many ways you can go. One way is recognizing that sine squared plus cosine squared is 1. So the next step could be, like I'll show, this is option 1 here. I'll try not to show too many options, but option 1 is you could replace that with 1. And so then you could say that this is exactly the same thing. Honestly, that might be the easiest and the fastest way. I know that sine squared plus cosine squared is 1. That's one of my identities, okay? So we can use any of those three identities at any given point to help us prove. And I now have it looking exactly the same. So that's one way to get to an answer. Another way could have been to clear out your denominator, and you could have gotten sine x, or sine squared plus cosine squared equals 1, because you have the same denominator on both sides, right? Those would cancel out. That's another option. And then you could claim that this is true by Pythagorean identity, or you could even take it a step further, substitute again. You could say 1 is 1. So there's so many different ways you could go here. And as long as you are showing me that they are either exactly the same visibly, or if you end with something like I have in pink here, sine squared plus cosine squared is 1, that's fine to stop there, but you have to tell me why. Because those don't look visibly the same right now, so you tell me that's an identity. Like, you have to be able to recognize, hey, this is an identity, I can stop, that's true. Or avoid that and just plug in, substitute, right? 1 is 1. That is true. That's visibly the same. Okay, so that would be the first one. So let's go ahead and try the second one now. So we have a different variable. We're using y now. That's okay. Y would still be in radians, though. It's not a Greek letter, so we wouldn't say that's degrees. This would still be in radians. And so I want to just go through and make sure that I can subtract these two, right? This is 2 terms over here. I only have 1 term right here. So I definitely want to combine those. And I also want to get everything in terms of sine and cosine. That might make subtracting these fractions a little bit easier. Because right now I'm working in 4 different trig functions. That would be a lot to try to get to look the same and combine. So let's try to rewrite all of this. So secant is the same thing as 1 over cosine. divided by cosine on the bottom. So that first fraction, all I did was change secant into 1 over cosine. Minus tangent is the same thing as sine over cosine, divided by cotangent is the same thing as cosine over sine. Okay, and that's equal to 1. So this looks kind of ugly right now, but we can divide these two fractions. So I'm going to, again, treat these as two separate things. Divide the first fraction, divide the second fraction, and then I can try to see if I can subtract them. So this first fraction, I keep the numerator the same, 1 over cosine, but I multiply by the reciprocal. So when I divide two things, that's really the same thing as multiplying by the reciprocal. So cosine of y, the reciprocal of that is 1 over cosine y. Minus, then I keep my second fraction, the numerator, the same, but now I multiply by the reciprocal. So I'm multiplying by sine over cosine. So this is what I have. I took that first fraction here, kept the numerator the same, multiply by the reciprocal, subtract, keep the numerator the same, multiply by the reciprocal, so we flip. And so now I have everything looking a little bit more linear versus fractions on top of fractions. That can get kind of ugly. And now let's simplify still each fraction one at a time. So notice how I'm just taking it one step. Just trying to simplify each fraction, then try to subtract, then try to get it to look alike. So 1 times 1 is 1. Cosine times cosine is cosine squared. Sine times sine is sine squared. And then cosine times cosine is cosine squared. That's equal to 1. Okay, so that is, again, all I did was just multiply those two fractions together individually. Now I can subtract. We want to check, do I have a common denominator? Thankfully, I do. So this would have only worked out if I did what I did here, where I got everything in terms of sine and cosine. Otherwise, you would have had a hard problem. So you want to always try to get sine and cosine because sometimes that denominator may appear. So I have 1 minus sine squared over cosine squared equals 1. Okay, so they are the same denominator, so I can subtract 1 minus sine squared. Sorry, I'm forgetting my y after these. Okay, I think that was the only y I forgot there. All right, so now you have a couple things that you could do. You could multiply by cosine squared on both sides, and then that would technically be a form of the identity. But I think the best habit to practice is the substitution habit, is recognizing, okay, well, what is 1 minus sine squared y? Like, I recommend just substituting in because that often kind of opens up the answer and opens up other doors for you as well. So if I know that sine squared plus cosine squared is 1, then 1 minus sine squared is cosine squared, right? If I subtract sine from the other side here, if I subtract that, I'm left with cosine equals 1 minus sine squared. Therefore, this entire thing is cosine squared, right, according to my identity. So therefore, I can say that cosine squared over cosine squared is 1. And I know that anything divided by itself is 1. Therefore, 1 is 1, and I have it proved. So that's what I would do, okay? Again, you could have multiplied by 1 on both sides to clear out that denominator. 1 times cosine squared is cosine squared. That's a derivative of the Pythagorean identity. You could have stopped there, claimed by identity, okay? But I think if we can get to this, if we can get it to look exactly alike by substituting, to me, that's usually the fastest, the easiest, and it just helps us practice the idea of substituting things in there. Okay, so let's go ahead and keep going here. So same issue. This one, we have something else that we can do, a new trick that, well, not new, we've been doing this before, but something that we haven't really done yet with manipulating, but it's a really good manipulation tactic for these equations. Okay, so right now I have cosine x, and then over 1 plus sine x, 1 minus sine x over cosine x. So here's where we're at. This is one where you would totally get stuck on without any kind of other problem-solving skills, because everything's in terms of cosine and sine. I have a 1 but I don't have the square. And so this is where we kind of run into an issue, all right? I do not have the squares. So I could not replace 1 minus sine 1 minus sine squared is something, but not just 1 minus sine. And so if this happens, we want to try to get one of those to be squared, okay? So let's kind of talk about what we can do here. So something that we've done a long time ago was multiply by a conjugate, okay? Multiply by a conjugate. And so this is a really good skill to have if you're trying to kind of get more sines or more cosines. Increase the exponent on your variable. If you're trying to manipulate the equation, if you're like, oh, I'm so close, this is almost an identity, but I need one more sign, I can multiply by the conjugate. Okay, so remember the conjugate is the opposite sign. So if this would be my term, 1 plus sine x, its conjugate would be 1 minus sine x. Okay, so that's what a conjugate is. It's the opposite sign of your expression. So if I originally have 1 plus sign, 1 minus sign would be the conjugate. Remember, we would do this process, again, if I'm trying to clear out middle terms. But in this case, when we multiply, you'll see what happens. So let's go through this process and let's see kind of where we're at. So let's multiply just one of the fractions by a conjugate and see where that goes. Now, you could do both, right? I could do both, but it's usually not needed. So let's just start with one, go from there and see what doors kind of open up. And that's why this is a hard lesson, because we are so quick to want to clear exact process through. That's not the case anymore. There will be times where you do something and that's totally wrong. You need to erase and go back. That's okay. Okay, so just kind of keep going. Try it out. See what happens. The more you try, the more you'll be able to kind of forward think of, okay, where am I going here? So let's multiply this whole first fraction by the conjugate of my denominator times 1 minus sine x. Let's just start there and see what happens. Okay, so this is always an option if you're trying to get more sines or more cosines. We need it squared instead of just to the first power. So on the top, I'm going to leave that alone. I'm not going to distribute until I kind of see what the denominator looks like. So we're just going to leave it alone. We may need to distribute. We may not. Just leave it for now. And then we'll kind of look at my problem overall and see where I need to go next. Okay? So on the denominator, when I multiply my conjugates, I'll show this work off to the side here one time. Then hopefully you don't need to do the work as much. You can just kind of remember that pattern. So remember, look at what this does. I take 1 times 1, which is 1. 1 plus sine x. And then negative sine x times 1, so that's minus sine x, and then minus sine squared x, because I'm taking sine times sine, which is sine squared, positive times a negative is a negative. So again, we would use the conjugate if I'm trying to clear out these middle terms. So, right, because if you multiply by the conjugate, one's going to be positive, one's going to be minus, so those middle terms are always going to go away, and look at what I have now. I have 1 minus sine squared, okay? Right, I increased the amount of signs that I have, right? And again, I can do this because I multiplied by top and bottom. I'm not changing the value, I'm just manipulating it. So if you're ever stuck in any math problem, this is a really good skill to have. If you're trying to get more of something, more x squareds, more sine squareds, you want it to be sine cubed, just multiply by the conjugate. And you can kind of start increasing the amount of signs that you have in the problem. So that's my denominator now, 1 minus sine squared, which now is an identity. That's equal to 1 minus sine x over cosine x. Okay, and so at this point, now I can kind of go from here and see, all right, do I need to distribute? Do I maybe need to multiply by the conjugate on the other side? Well, let's take a look. Right now, I could replace something, right? I do have a sine squared now. That's good. I can use the identity. So I always recommend trying to replace, right? Because that's going to turn something that's 2 terms into 1 term, which is what I want. That denominator on the other side is just 1 term. I don't want 1 plus something or 1 minus something. Let's replace that. So that is the same thing as cosine squared, right? If sine squared plus cosine squared is 1, then 1 minus sine squared, right? If I subtract the sine squared over, is the same thing as cosine squared. So I'm going to substitute here. So we know cosine of x of times 1 minus sine x over cosine squared is 1 minus sine x over cosine x. So that would be my next step, is try to substitute. Try to break down, make smaller. Okay, 1 minus sine squared, now I turn that into 1 term. And we can kind of see what's going on. Look how close we are to this side. I have a 1 minus sine x on the top. I have a cosine on the bottom. I have 2. Look what I also have on the top here. I have 1 cosine, 2 on the bottom. I can reduce. Think about that as x over x squared. 1 on the top, 2 on the bottom. I'm going to reduce the 1 on the top and get rid of it, right? Divide it out. Now I only have 1 on the bottom. So I'm left with 1 minus sine x over 1 cosine on the bottom is equal to 1 minus sine x over cosine x. And now I have shown that they are equal, okay? Again, this will always work out. I'm never going to give you a problem that is false. They will always be equal to each other. So you just kind of slowly manipulating your way through, you will start to unravel it and see that, oh, hey, this is going to work out really nice for me because they are equal. So this is a really good skill to have if you notice that you maybe have 1 plus sine or maybe you have 1 plus cosine. You don't have squared. So it's not an identity yet. Try to multiply by a conjugate to turn it into an identity. So that's a really, really, really good skill to use. Okay, number 4. We have sine x minus sine x cosine squared x equals sine cubed x. So I have a lot going on here. I have 2 terms on one side, 1 term on the other side. So I definitely need to try to condense that first side, that left-hand side, into one thing. But right now, I could not simplify because they're not like terms, right? This would be the same thing as trying to subtract x minus x y squared or something like that, right? Those are 2 different variables. Sine and cosine are 2 totally different things. So we would just be stuck. So using this though, kind of using this, right? If I say x is just going to be sine, x is going to be sine, and then cosine will be y, and I have 2 cosines, so y squared. If this was my problem here, it's circled in green, what could I do to maybe manipulate that? What could I maybe take out of that equation? What do I have the same? An x, right? So it's the same thing here. Factoring still applies. If you see that you have lots of the same thing in each group, factor it out. That can help, right? The whole point of factoring out is so that way I can kind of split it into 2 groups and maybe start to see, okay, well, what does that group maybe turn into? So yeah, I can factor out a sine x from both of those terms. That is something you can always do. We can always still factor. So when I divide sine x by sine x, right, because that's what I do. When I factor something out, I'm dividing it out of that term. That's 1. And whenever I divide from my next term, sine x over sine x goes away. I'm left with negative cosine squared x equals sine cubed x. And so now I can see that I have an identity that is there. So I have 1 minus cosine squared x. I know this is an identity because I'm dealing with a 1. I have a minus or a plus sign in between, and I have something squared. So we can go back to my identities. We have sine squared plus cosine squared equals 1. And so therefore, if I subtract cosine squared to the other side, sine squared is 1 minus cosine squared. So I'm going to replace that with sine squared, okay? And so that allows me to now have like terms that I can multiply, right? So I can multiply sine times sine squared. So I have sine to the first power, sine times sine to the second power. When we multiply exponents, we really add them. So this would be sine cubed x equals sine cubed x. I have proven it, okay? So that is an option as well. Not only can we multiply by a conjugate to increase the amount of variables or like my power on one of the sines or the cosines, but we can also factor. Right? Factoring allows me to turn any kind of subtraction really into a multiplication looking problem like how we did here, and allows me to maybe substitute something in. Okay, last one here. It looks more complicated than what it is. So let's go ahead and let's just kind of rewrite some things in terms of sine and cosine. I think that's going to be my first step here. Yeah, okay. So this top part I'm going to leave alone. Sine y plus cosine y. Those are already in terms of sine and cosine. This is probably the hardest one that we'll see, but it's actually not too many steps. It's just kind of going to look weird, and so we need to get used to what operation is happening between everything. Okay, so cosecant is the same thing as 1 over sine. So that first side of the equation is now all in terms of sine and cosine. It looks ugly. We'll get to it, okay? So then that's equal to tangent. Tangent is the same thing as sine over cosine. Divided by secant is the same thing as 1 over cosine. And then that's getting multiplied by 1 plus 2 sine y cosine y. Okay, so this is what we have. This looks pretty bad. But let's try to simplify any of those divisions, okay? That would be my next step, is try to bring everything to that main line. Right now, I'm working in my numerator and the denominator. This doesn't look very good. So let's divide the first term there. Let's divide the first term on the right-hand side of the equation and then see maybe where we're at, if that maybe turns stuff into identities or if we need to go further. So what we do, right, is we keep the denominator or the numerator the same. So we're going to keep the numerator the same here. I multiply it by the denominator flipped. So for this first one, I keep the same sine y plus cosine y squared, but I multiply that by sine y over 1, or just sine y, right? I flip it. So that's division. You multiply by the reciprocal. That's equal to, I keep this numerator the same, sine y over cosine y. I multiply that by 1 over cosine y flipped. So cosine y over 1. That's still getting multiplied by this group in parentheses here. Okay, so I have kind of a lot going on here. I can cancel out my cosine y's. Okay, I can cancel those out. And now we're really just kind of, I'll rewrite it. You don't have to rewrite it, but just for the sake of this problem, I'll rewrite the next line one more time. So maybe we can see how we're very, very close. We're very, very close to having this looking exactly alike. Sine y, I'm going to put the sine y in front. So on the left-hand side there, I'm going to use my commutative property. I'm going to flip the order there just so things look a little bit nicer, and I can maybe see some comparisons between the two. So sine y times sine y plus cosine y squared, right? Just flip the order there. That's allowed. That's equal to, the only thing that I had left from that fraction was sine y, because my cosines cancel, times 1 plus 2 sine y cosine y. Okay, so this can happen a lot too in math, where really our answers or our final proofs are going to be a big, long kind of situation happening where it's not going to fully simplify to maybe just one thing. So I'm very close, right? Notice how each group on either side here has a sine y in the front, but this and this are different, right? What I have in the parentheses. So what I recommend doing at this point is you want to try to manipulate one of these to look like each other. And in this case, I would try to manipulate this one, right? This one can't be simplified any further. 1 plus 2 sine y cosine y. Those are two totally different terms. Cannot be simplified. But I could try to foil this, right? I can multiply sine y plus cosine y times sine y plus cosine y. Let's try to manipulate it to see if it's going to match up. So this is a good skill to have as well. You could say, hey, I notice that I have 2 sine y's here. So this is giving me a hint that these parentheses, what's behind it, should match up, right? Because again, I'm not going to trick you. I'm not going to give you something that's not true. So if we can turn that first term, like that first kind of group of parentheses to match that second group of parentheses, I'm good. So we can show that work off to the side here. So let's do that. So let's FOIL sine y plus cosine y, or multiply, right? Distribute. We won't use the word FOIL. Sine y plus cosine y, right? That's all that is. Sine y plus cosine y squared, that's the same thing as this. Sine y plus cosine y, 2 times, okay? So let's go ahead and try that. So we have sine times sine, which is sine squared. Sine times cosine. So that's plus sine cosine. And then sine times cosine again. To make this really nice, I'm going to write plus sine cosine in that order. Again, multiplication is commutative, so I can just kind of flip the order. I'm going to keep sine first. Typically, that's how you'll see it in math as well. And then cosine times cosine is cosine y, or cosine squared y. So I can then combine like terms. And so I have sine squared plus 2 sine y cosine y plus cosine squared. And so that is how we FOIL, right, or distribute. So that's the same pattern every time. You square the first term, you double those 2 terms multiplied together, you square the last term. That is, we've done that. That's our binomial expansion. That's going to work the same way every single time. And so look at what I have now. I see a piece of this, right, this sine, 2 sine cosine y. I see that in my answer. But my answer over here also has a 1. Well, this is where now we need to think. Sine squared plus cosine squared is 1, right? So these terms, this is a identity. Sine squared plus cosine squared is the same thing as 1. That's why this is going to be so important for you to have these memorized, because otherwise you'd just be staring at this problem. So I can replace sine squared with cosine squared with 1. So this really becomes 1 plus 2 sine y cosine y. And so I've shown that this right here, that group of parentheses, sine plus cosine squared, is the same thing as 1 plus 2 sine y cosine y. Therefore, these two are equal. So this is the same thing as sine y times 1 plus 2 sine y cosine y, right? I showed that work, equals sine y 1 plus 2 sine y cosine y. So this is a good example to show, hey, you're not always going to have it wrapped up so nice and neat. It's not always going to be 1 equals 1 or sine equals sine. You may have an ugly answer. So these were kind of the weird cases, right? This isn't every weird case. That would take me 20 years to try to explain you every weird thing that could happen in math. But this is probably the majority of what we'll see for right now, okay? So again, this is, you have some weird answers. You can always kind of try to manipulate one side to the other. You may not even need to use that many identities. You can also factor. We don't want to forget about factoring. That's very important. We can multiply by a conjugate, okay? So 3 weird cases that should help you out with some of that homework, okay?